In this video, we're going to have a look at linked lists. A linked list differs from an array in that the data stored within a linked list is not indexed. With arrays, we're used to typing in an index in order to access a particular value. Usually coincides that the index relates to the value, and therefore it's much easier to access this value because we would know the index. However, with a linked list, because we don't have the index for a particular piece of data that we may want to look up, we actually have to iterate through the list elements, or we're going to refer to them as nodes in the linked list, in order to match a value that we're searching for with a value that's stored in one of the nodes. And so each node contains both either a piece of data or multiple pieces of data. This could be attributes of a class, say. And importantly, each node contains a pointer to the next node in the sequence. And this pointer is a real pointer to the memory address of the next node, which may look like an object of a class. That's what we're going to be modeling for the exercises that correspond to this video. And then that node contains a pointer to the following node, and so on and so on. And hence how you get this sequence of nodes which are linked together until you get to the end of the list, in which that last node contains a null pointer, or sometimes referred to as a null reference. Okay, it doesn't point to a node, but it still contains an empty pointer, just in case something is appended to the end of that list. This UML class diagram recommends that we create two classes to model our linked list. The class on the left, called link, is how we model the entities that we want to store in the linked list. So we've called it link, but this is the node class. So whatever objects or items that we intend to store in the list is going to be modeled in this class. And you'll see here we've got an attribute called data. It's an integer variable, and you'll also see the pointer to the next node, the next object of this class. And as this class is called link, you'll see it is a pointer of type link, and the label's called next, and so this is how we can access the next node, next link in the linked list. Okay, and then on the right, the second class is the linked list class, which, as always, the typical design of these data structures, this class is the management class. It contains all the methods and attributes to manage the operations that the linked list will perform. The linked list class does actually contain a pointer itself. You'll notice here one of the attributes is a pointer to the first node in the sequence. And this is typically where we start. So the first node in the sequence is where we can access the nodes that come after that first node. Okay, we need a starting point in order to traverse the linked list. So in the next slides, we're going to take a deeper look at how the operations such as insert, find, and delete work. One of the main advantages to using a linked list is that insertion or deletion of nodes doesn't affect the remainder of the list. With an array, if we wanted to insert a value at the start of the array in the first element, we'd have to move the consecutive elements down a position. But with a linked list, we can easily insert a node at the start of the list. We just have to set the new head of the list to have the next pointer to the old head of the list. And we don't have to change any of the positions of the remaining nodes. And this is the same with deletion. If we want to delete a node in the middle of the list, we just have to change the next pointer from the node before the one which wants to be deleted to the one which is after the one which needs to be deleted. The only thing we need to be aware of is that we must change the pointer before we delete the node, because otherwise, if we delete that node before we change the pointer, we'll lose the rest of the chain. Okay, so this is why we need to take care not to split the structure. And we're going to see an illustration of this in the next few slides. In the exercises that correspond to this video, we're going to be prepending. That means we're going to be inserting nodes at the start of the list. And the advantage of prepending is that this operation can be done in constant time, O of 1. The time taken to add to the start of the list is unaffected by the size of the list, because we will always add to the start of the list. However, appending, adding to the end of the list, would take linear time, O of n, meaning that the time taken to iterate to the end of the list depends on how many items there are in the list. So if there's a small amount of items, it won't take very long. However, if we have a large list, it will take a long time to get to the end of the list, to be able to add at the end of the list. And of course, we have to repeat until the next pointer is a null reference. Okay, but back to prepending, what we're going to be doing in our exercises. As mentioned, the item we want to add to the start of the list, we have to make the next pointer point towards the old head of the list. That's how we add nodes at the start of the list. And with the delete operation, we first have to implement the find algorithm, which is one of the exercises that correspond to this video. In summary, the find algorithm will iterate through the list, looking at each node and comparing the value that we're looking for, in this case it's just an integer, with the data of each node. And if there's a match, we've found the node that we're looking for. But with the delete operation, we have to modify this algorithm slightly to keep a pointer to the previous node that we're looking at. We're going to maintain a current pointer, which is the current node we're looking at, and a previous pointer, the one before the current node. Because once we find the node that we want to delete, we have to change the previous node's next pointer, which would currently point towards the node that we want to delete, to point to the one next in the list, the one after the one we want to delete. So we have to change the previous next pointer to be the next pointer of the one we want to delete. Now, I appreciate that probably sounds harder than it seems. That's quite a mouthful. But as you can see in the illustration, actually the concept is quite straightforward. So it's just a case of coding that up. Okay, so that's what we're going to do in the next video. We're going to get started with implementing a linked list. Right, so let's get you started with linked lists then. The first thing we'll do is create a class for the link class, and then we'll have a go at implementing the linked list with it, which we've actually been given the code for. Okay, so we can get started with that fairly quickly. All right then, so let's start off by adding a class for the link, which, remember, that acts as our node. Nodes that make up the linked list. So let's define the structure for that. And it's a reasonably straightforward one for these examples. We've just got an attribute for the data, which is an integer value. And then we've just got to point it to the next node or link in the chain. Okay. And then let's implement the constructor. So let's say link, and it's a non-default constructor, takes a parameter, which we're just going to assign to the class attribute data. Okay, so that's fairly straightforward. And then we've got the display method, which doesn't return anything. It just prints out the value of data to the screen. Okay, and then as we're using cout, we're going to need to include iostream, and then write using no space std. Okay, for display, and then just one more. We've got get data, which just returns the value of data. Just a standard getter method. Okay, so return. Okay, so that should be the link class completed. Let's go down to exercise 2 and then implement the link list, the management class. Okay, and rather handily, we've been provided with most of the code for this. So this shouldn't take too long. So link list. I'm just going to create the header version just to keep the code all in one place to make it easier to see for this video. But I say if you want to use the header and the CPP files, that's absolutely fine. I'm just going to copy that from there to there. And I also need to include link.h so I get access to that. And let's just write the implementation out here. So for the constructor, it's just initializing the first pointer. Is empty, which is should be fairly familiar to us. It just turns true or false, depending on whether or not the linked list is empty or not. Insert's going to be prepending, so we're going to be adding the items to the start of the list. And then display just iterates through the list, starting at first, and then prints them to screen. Okay, and actually calls the display method of each link node. So that's where it gets the it refers back to this. Okay, so that should be that. What's next? Within main, just create an instance of it. So I need to include link list, which also includes link, so I don't technically need to include link within here. Let's create an instance of it. Just call mine LL, short for link list. Don't need to pass anything to the constructor here. Don't need to set a size or anything, because remember it's a dynamic data structure. It can grow and shrink as required. But I just will call the insert method, which takes a parameter of type link. So I'd need to declare a new link object, which essentially acts as a wrapper for my integer values. Okay, so it's that format. Then I'm going to want to repeat. We're instructed to add 6 links, but just to save time, I think I'll just add 1 or 2 for now. And let's just check that we are indeed adding them correctly. So let's call the display method, and then see what we see on the terminal. Okay, yep, and you can see there it is printing out those items which are added. And of course, interesting to note, it's printing them out into the reverse order in which I've added, because remember, as we add a new item, it prepends, so it adds them to the start of the list and moves all the other items down. Okay, so that's a quick demonstration of exercises 1 to 2. Once you've coded that up, have a go then at the rest of the exercises from then on, implementing methods for finding the items within the list, and then there's other ones as well for delete and various other exercises. Okay, so give that a go and see how you get on.